All right, now we're going to talk about hypothesis testing. And Tony, are we recording this one now?
We sure are.
This might not work, but let's roll with this, okay? So
Okay.
keep your mic on. So let's review so far that we've talked about it. A histogram can be thought of in terms of probability. This is a bit of a mind bender. Most people think a histogram just shows like what percent of people have certain values, but we can think of it in terms of if I randomly pick somebody, what's the chance they would end up in certain spots? If you took stats before and you didn't understand what a p-value was or what confidence intervals were, it may be due to this. We've also talked about this idea in a normal distribution. We know most people are within 1 SD, almost all are within 2, and so on. And we can reference these people using z-scores, which is how many standard deviations am I from the mean? And the next thing we need to talk about is another weird concept, is this idea of the null hypothesis. And once we have this null hypothesis, we can start to say things like, what's the probability of getting a value in here if the null hypothesis is true? What's the probability of getting something like this if the null hypothesis is true? What's the probability of getting something weird way out here if the null hypothesis is true? And what you'll come to realize very quickly is that this curve is going to be sort of what we would expect if the null hypothesis is true. Then we go out and get our own data, we plot it somewhere, and we say, what's the probability of getting my data if the null hypothesis is true? And that's the definition of a p-value, okay? But we need to think about a little more about what is this null hypothesis. So I came up with this example. This is kind of a stupid example, but stay with me for a bit. Let's imagine that everybody has an enzyme in their body called the NKE, the Nike enzyme. And it's a naturally occurring thing, and it has this nice normal distribution. On the average, people are average, some people are low, some people are high. The mean is about 1,000, and the standard deviation is about 100. So now you should be able to picture exactly what that curve looks like. Here's 100, here's 200, here's 300, and so on. So let's imagine that this empirical distribution comes from drug-free, elite, fit, healthy athletes. This is the distribution of this enzyme. All right, now stay with me for a second. We know, if you know one thing about elite athletes, is they try to cheat, and they will put anything in their bodies that might help their performance. So let's say word on the street is that NKE will increase your strength or your stamina or your power or what have you. So people are starting to supplement with this thing. Now, we have a job. We have to make sure that people are not trying to cheat. So imagine further, there's a rule, no more NKE supplementation. You have what you have, and that's it. If you're low, you're low. If you're high, you're high. If you're in the middle, you're in the middle. But if I catch anybody trying to cheat and get their level up, then we're going to blacklist them. We're going to take their medals away, and so on. Okay, so here's our null hypothesis. Drug-free, elite, fit, healthy athletes have a mean of 1,000 and a standard deviation of 100. Okay, now we have a job. We show up at a sporting event, and at this sporting event, we think people might be trying to cheat. So we have to come up first with some null hypothesis. This is called the H null or the H naught or the H sub zero. We say, let's assume that this person is drug-free. And then we'll say, if they're drug-free, what's the chance that they would look like this? So here we go. Let's say we test an athlete. We're at an Olympic weightlifting competition. The first athlete we test randomly is this man named Dmitry Klokov. He's a Russian weightlifter. His dad was a champion weightlifter. He's an incredible man. Let's see, we show a quick little video of him here. He's doing a lift, which is called the clean and jerk. And the clean is where you lift the weight up to your chest like that. And then you jerk the weight overhead like this. Very difficult lift to do. You have to be very strong and very powerful in order to do that. Now, that was over 220 kilograms, 485 pounds. That's a lot. Now, if we test him Let's say we get an NKE level of 1,100. Now, what do you think? Is he a cheater? Antonio, are we still recording?
We're still recording.
Okay. Do you think he's a cheater? We have a guy here. I know you're not a statistician, but the mean's 1,000, and this guy is one standard deviation above the mean. Do you think he cheated and tried to supplement up to that level?
I think it's possible.
It's possible. What else is possible?
Maybe because he's such a great athlete that he just has that in his body, like you were talking about earlier.
Yeah, but remember, this distribution, all these people are great athletes, right? All these people are elite, fit athletes. He just happens to be a little higher than average. Is he weird?
I guess not.
He's really not that weird, right? He's not that weird.
No.
A lot of people are that weird. So let's say we randomly pick another athlete. This is Kendrick Ferris. He's one of the strongest Americans. He's from Louisiana. Let's say we randomly test him, and we get a number of 1,200. Now, he's 2 standard deviations above the mean. Is he a cheater? Antonio,
I don't know.
You don't know, right? We don't know. That's what's important. We don't know. But we can answer this question. If he is from the population of drug-free athletes, what's the chance we would randomly get somebody who's up here? It's smaller than the 1,100 that we saw for Dmitry Klokov, but it's still, is it weird enough that we should be on our radar? Maybe we should take his medal away. I don't know. Let's think about this. Let's say we randomly test one more guy. This is possibly the strongest human being who has ever lived. And yes, I've watched Game of Thrones. Let's say we randomly test this guy and his Nike level is 1,400. Well, we know a little bit now. We know that if you take 1,400 and you subtract the mean and you divide by the standard deviation, this guy is 4 standard deviations above the mean, a z-score of 4. Is he a cheater? Should we go to Iran, take his gold medal away?
He's certainly off the charts.
He is off the chart, yeah. And so the question really becomes, at what level would we label someone a cheater? At what level would we have to say, this is what we would expect to see if somebody was drug-free, but now we see somebody here and we say, what's the probability of getting him if he actually is drug-free? It's very, very rare. So as a group, we almost have to decide ahead of time. What would have been really nice to do before we started recording this one, we should have said, hey, what is the cutoff of weird? What level are we going to say that level is way too weird? And if I see anything above that level, I'm going to go back to my original assumption, that null hypothesis, and I'm going to say that null hypothesis, probably not true. I have to reject it. This is a really important number in statistics. It's called the alpha level. And the alpha level is, what is your criterion for weirdness? At what level are you going to say, wow, that dude is really high. I'm going to reject that null hypothesis of innocence, of clean. So we use the Greek letter alpha for this, just something like that. And it is, what is the criterion we're going to use to say that something is weird?